apply. What is the value of a? Given that a does not equal to 0, from here we have 5 to the power of a minus 4 to the power of a equals 369. Now let's raise the power of this 5 to the power of a by 1, the power of this by 1. Now again, we can have 1 to be equals 2 over 2. So when we replace it here as 2 over 2, so now again, from the law of indices, when you have a to the power of m in parentheses to the power of n over n, we can have this as a to the power of m over n to the power of n, as we have it like this. So now from here we have here to be 5 to the power of a over 2 Now, from here, let us now define the following. Let to be equals m to be equals n. So when we have 5 to the power of a over 2 to be equals m and 4 to the power of a over 2 to be equals n, so therefore from here we are going to have m squared minus n squared equals 369. And let us recall that when we have a squared minus b squared, we call this difference of 2 squared equals as a plus b in parentheses multiplied by a minus b in parentheses. So when we apply it here, we have m plus n times m minus n equals 369. Now, from here, we have to take note that m plus n in parentheses always greater than m minus n because of this negative. And again, this 369 can be expressed as the product of 41 times 9. So from here, we have to consider this, because when we also have 9 times 41, it's only this one we're going to consider because of this expression. So from here we have m plus n so from here. Now, having known this one as this, we can now equate. By equating, we have m plus n equals 41. Then m minus n equals 9. Now there's need for us to solve this simultaneously by adding them together. M plus n will give us 2m. This will cancel out this. We have 41 plus 9 will give us 50. Now, so from here, divide through by 2. So we have our m to be equals 50 divided by 2 will give us 25. Now, also we have, let us recall, we have our m to be equals 25. We want to get the value of n too. We have m plus n equals 41. Then m minus n equals 9. Then to also get the value of n, let's subtract. If you subtract this minus this will be equals to 0. Then this will be plus n minus n equals, this one will be 41 minus 9. 41 minus 9 will give us 32. So from here we have n minus times minus will be plus. Here will be 2n equals 32. Now, we also have to divide through by 2. We have n to be equals 32 divided by 2 will give us 16. So therefore we have m to be equals 25. Now, we have to recall from where we have our 5 to the power of a over 2 to be equals m. And our m equals 25, so we have 5 to the power of a over 2 to be equals 25. Then we can have this 25 in base 5 as 5 to the power of 2. So we have 5 to the power of a over 2 to be equals 5 to the power of 2. Now, from here they have the same base with different power. So by equating the power, since the base are the same, so we are going to have a over 2 equals 2. Then when you cross multiply, we have a to be equals 2 times 2, and we have our a to be equals 4. Now, for the second problem, recall that we are given our n to be equals 16, and there's a where we have 4 to the power of a over 2 to be equals n. So from here we have 4 to the power of a over 2 to be equals 16. So we have 4 to the power of a over 2 to be equals 4 to the power of 2 will also give us 16. Now equating the power, since the base are the same, we have a over 2 equals 2. Cross multiply, we have a equals 2 times 2, so we have a to be equals 4. So since our a is 4, now we have to check recall we are given 5 to the power of a minus 4 to the power of a equals 369. Now, when a equals 4 from the above, so we are going to have 5 to the power of 4 minus 4 to the power of 4. That's going to give us 369. So 5 to the power of 4 simply means 5 times 5 times 5 times 5. And this will be 625. Then 4 to the power of 4 simply means 4 times 4 times 4 times 4. This will give us 256. then it's going to give us 369. Now from here, what we are going to have will be, let's subtract. From here we have 625,256. So it's impossible. When we take 1 to the 612, this here will be given 11, this here will be 15. Now 15 minus 6, this will be 9. 11 minus 5, this will give us 6. Remember, this one will be 5 minus 2, this will give us 3. We have 369 equivalent to this 369. So since we prove the left hand side to be equal to right hand side, this tells us that A equals 4 is perfectly correct.